Hi, my name is Chris Knight, and I'm going to be demonstrating the third extra credit assignment for MATLAB, and this is for ENGR 267 Engineering Programming at OIT for Dr. Mateo Aboy and James Eastham. In this simulation probability problem, I have 6 perfect hunters, which are each independently shooting at 6 identical ducks. They each are allowed 1 shot, and they can shoot any of the ducks that they wish. One of these ducks has been identified for research purposes. My simulation is supposed to calculate the probability that the research duck is going to survive and what is the mean number of ducks that are going to survive the shooting. So looking at the function, the script, I did this similar to the way I've done the last one, where I've created debugging output, where I have a verbose output, a debug output, and I've also allowed for plotting a histogram just for the fun of it. The script itself is all inside of one for loop, and it is running a simulation. Here we are choosing which hunter is shooting in this for loop, and we're choosing which duck they're going to get shot, and we're calling a duck function, which is an anonymous function written here, again using the rand_i, which is a normally distributed random integer function in MATLAB, and here I'm passing a parameter into it, so I have 1 through 6 ducks, and it is supposed to, according to MATLAB's documentation, give me a normal distribution. And basically what that function does is it decides which duck the hunter 1 through 6 is going to shoot at. And I can actually change this to include more ducks and more hunters if I wanted to say, okay, we have 50 ducks and we have 6 hunters, or whatever. So this section is the simulation. This section is calculating the statistics. It's again using the standard probability function, which is just dividing the number of successful events by the number of tests. And I have it again with the ability to create any number of tests that I want, which is basically numbers of the times that the simulation will be run. And then here's just the portion for displaying the histogram of the survival rate. So let's run this. And I'm running it right now without verbose and without debug and without a histogram. And it's been run for 10 simulations. So it's going to run 10 times. The output is, with 10 tests run, the probability that a research duck would be survived was found to be 0%. The mean number of ducks that survived was found to be 2.1. So in this case, with 10 tests run, that research duck was shot every single time. So let's look at this with a little bit more information. Let's look at this with verbose output. I use this when I was doing the debug so that I can make sure that what is actually being output is really what is supposed to be happening. What this is telling me is that hunter number 1, and it's counting for each, through this loop, it counts each hunter, and then each hunter has a chance to shoot any one of the ducks using this function. So hunter 1 shoots duck number 3, hunter 2 shoots duck number 3, hunter 3 shoots duck number 5, and the reason why we have doubles here is because any hunter can shoot any duck. So, you know, it's probably quite unlikely, but all 6 hunters could shoot the exact same duck if it just turned out to be that way. In this case, hunter 5 and 6 both shot the research duck. And so what we see here is just it run 10 times, and I'll kind of run it together here. We can get more information by turning on debug output, and that is going to give us a handy little, this is the flock representing duck 1, 2, duck 3, 4, 5, and 6. And then we're going to count through each one of the hunters, and we're going to see visually which duck the hunter shot at. In this case, it doesn't change because both of them shot the research duck. They both shot the same one. So in this case, same thing. We had the same duck number 6 get shot. And then we see for each one of the 10 runs through here how many ducks survived. And this happens for each one of these. So we can also show a histogram of what's going on here. Let's increase the number of, where is it? Okay. Let's say we're going to run it 1,000 times, run the simulation 1,000 times, see what the chances of that research duck surviving are. Oh, I didn't have to show the output. Oof. Well, that would have been quite fast if it hadn't been displaying all the output. And we can see that it actually is a normal distribution for survival rate of the total ducks. But for the survival rate for just the research duck, it's really not all that normal. What else? I guess that's pretty much it. Thank you. Oh, this concludes my demonstration. Thank you.